As you can see, we've got an SMC rig here, completely blank slate, nothing on it, and we're going to turn it into a big project.
We're going to turn this
into this. My name's Kieran. Hey, look, I'm trying to become an engineer. Listen, I'm a little bit of an engineer.
So, Kieran, what controls the system?
Well, I think it's a great thing you asked that because we have 2 PLCs, mainly just because we're poor. Well, these PLCs, they only have one Ethernet port, which is not the best. So we have to put them both through a switch, and both of these PLCs are now speaking to each other. They're in constant communication with each other, passing specific variables back and forth that we've done.
So what was the inspiration for the project?
Last year, we were training for World Skills Automation. And we walked into this room, and I remember saying to you, we looked at this rig, we said, we wanted to build that. We're going to build that. And so we did, with no experience at all, little to no help. And what can you expect? It looked like this.
Beautiful. You ready?
That's pretty shit. Nobody likes a rat's nest for a control system. This time around, we said to ourselves, we're going to improve that. And we did. This thing looks beautiful now. It's going to run for a lifetime. That's what you want in a control system. Reliability.
You know, with that being said, I mean, let's get right into the building now. How much of this project was already pre-built before you even started anything?
Nothing. Nothing was built. It was just a wreck. It was a rig ripped to bits. We came to it with no manuals. This is what it is. We looked at it and we were like, you know, we can figure this out. And we did. I mean, in the process, I did fry sensors. I did fry most of the sensors, but that was a learning curve, right? If I'm telling the truth, some of the things on this board was already made. But in comparison to the stuff that we produced, designed, and assembled, that's nothing, man. That's peanuts, yeah? But all this conveyor belt stuff, we were coming to it fresh. No experience, no idea. So all the timings, all the PLC program that surrounds this, all the sensors, everything is just, it's got a story to it, right? There's suffering behind it, there's joys behind it, full bag of emotions.
This is the real question, and I want you to be completely honest with me. On a scale of 1 to 10, how much do you like push fits?
Sorry, can you say that again?
Look, listen, I'm not messing around. How much do you like push fits?
I can't believe you're asking this.
How much do you like push
I can't
fits?
believe you're
Answer
asking
the question,
this
Igor. Answer the question. Answer the question.
You know how I feel about push fits.
Answer the question.
You know how I feel about push fits. I hate those things. Give me out! Give me out! So the rig is looking a bit of a mess right now. We're still in the process of building things up, but we have successfully completed the first sequence, which I'm going to show you guys now. So the sequence begins when I press the start button here. So that's basically the end of the first sequence. At the moment, we've just got it coming back and popping it back down. So the question is now, how do we take this block onto the conveyor belt, okay? So what we're gonna have is we're gonna have a piston that we managed to find in one of these drawers. We're gonna have that come out, and once that's come out, which we've got a sensor here, sensing that piston's come out, we're gonna send this piston D out as well for it to push the block. That's the plan right now. See if we can execute it.
Then we cut our belt, gathered the materials, fixed the pillars, and we were ready to see if this thing worked.
So guys, we are at a pivotal moment in the project, aren't we, Kieran? We're about to see if this contraption will work or not.
See if it fucking blows up. So we have jerry-rigged. We 3D printed all this, as you can see. It doesn't look the best. 3 bearing holders, and we just... Oh, God. It's probably going to blow up. If it does, at least it'll be on camera, you know what I'm saying? 24-volt motor. We're just going to power it straight from the power supply. Just see if it works.
Let's do it. Oh, my God. It kind of works.
It kind of works.
It's definitely moving.
Yeah, I think it needs to be tensioned more.
Yeah. There's a lot of rubbish, I think, here. Why is this moving? There we are, there we are. Go on, stick a block on it.
Oh!
It handles the block.
Handles the block easily.
Okay, managed to pick it up.
Does carry the block. Can it get over the tape?
I mean, it really is struggling. It really
Here. This is the part, this is the problem. It keeps pulling out like this. That's not in there good enough. Right, for now, I think we'll be all right. I think we can just get all the arms in place because it's very fucking bouncy. It needs to be super tensioned. Yeah. It needs to be literally completely, like, there's supposed to be no bend in it. Yeah, no. It's actually not running too bad. To say this is first run. Obviously, the tape is questionable. That's all right. I'm happy with that for now.
So the initial design was shoddy. It was very much suck it and see, and we soon saw a critical design error.
Give me an arm with this. Give me well hard. Right. No! You fucking bitch.
So on the motor, we mount what we call the active roller. The active roller changes color a few times in the video because we keep snapping it and we keep making iterations. But one thing we got spot on was the interference fit. It just wouldn't budge off. So in the end, our active roller looked like this. We added the ribbed circumference so that the roller gripped the belt better. And most importantly, the fillet gave strength to an area which kept on shearing. It doesn't look easy. What was the hardest part of this project?
I'd have to say the conveyor belt. The conveyor belt was treacherous. It was terrible.
Kieran, there is a lot of brands out there that make pneumatic components. One of the best ones out there, Festo. So why have you used SMC gear?
Well, you know, Phil, that's a great question. Beggars can't be choosers in this case, I'm afraid. It's just what we had at hand, and it's just what we could use. It's mainly us that were the problem, but, you know, just this pneumatic arm alone has a lot more stuff than just a pneumatic piston, you know. There's a lot more things to think about. Same with this is a rotary pneumatic arm in this case. It's all a bit different for us.
So would you say that it'd be easier using a controlled way of picking stuff up like encoders, motors, rather than pneumatics?
Yeah, I don't know if I'd say it's going to be easier, but I'd definitely say it's more reliable.
Following this, Kieran and I discussed how we wanted this project to look in the future, and we came to terms that we wanted it to be fully automatic. This meant that we wanted to get the block off and on the conveyor. This would mean that the motor would have to run forward and reverse. To implement this, we would install a relay to be able to pass the bigger current. This is because the PLC output, which is a transistor output, isn't sufficient to supply the motor itself. Whilst Kieran was doing this, I temporarily installed the optic units, which are placed alongside the conveyor belts, and they are used to sense the block.
Oh, let's go, man! Holy shit, you cooked!
Another small win after initially shorting out the relays. We now had forward and reverse functionality on our motor. But as we know, when we solve one problem, another problem arises, and the problem now was the reliability of the intermediate piston, which we had some fun playing around with.
It just works. You didn't see anything. But it still works.
So I'm very impressed with the progress you've made in the project. It's phenomenal. How is this project going to improve in the future?
Well, it's a good thing you asked that, Phil. We plan to add quite a lot of things to it, to be honest with you. It's definitely not done, but for now, we're somewhat happy with it. Next year, our plan is to do a competition called Industry 4.0. So we're probably going to add a lot more automation when it comes to this. We plan to have a monitor up there, PC underneath, and we're going to make it so it's all hosted on a website. Any of you people have heard of Node-RED? You can connect PLC IOs, through JavaScript to a website. That's pretty cool. That'll go range from things just such as monitoring all the way to, controlling the system from maybe your phone. We hope to maybe change out the PLCs for something that we can use IO link with. I think it would make it look a lot nicer, and maybe we won't have to use two PLCs.
We've made a lot of progress since the last update video, and here's where we are at. First of all, we decided to install emitter and receiver light sensor, which conveniently goes to our last remaining fiber optic light unit. But right now we've got to go in straight into the PLC. That addition is so we can create a continual cycle for the whole system. I'll show you what I mean in a second, okay? I've had a lot of issues with this arm right here. It's caused us so much pain and suffering. We even snapped one of the positioners inside, so we had to replace it with an M8 bolt. So we actually cross-threaded this imperial thread with a metric thread. But it still works, it doesn't leak, so it's all right for now. And it has to move very, very slow. Otherwise, it'll move the internal cushions so that the alignment won't be right. Okay, this arm, we figured out none of the sensors work at all. That's because I may have fried them at some point before, but that's fine. We're just gonna use timers for this thing. And now, we're in the process of figuring out and trying to debug the code for this sequence, which I'm going to show you now, okay? So we made it to the button. You hold it down and it resets the safety relay. But if you just press it once, it also goes to the PLC, and it's just going to reset us back to step 0 in a sequence. And you get to see all the code in a little while when we made it nice and neat, because right now it's awful. It's tremendously bad. So if it's in auto and then press start, we start the sequence. This is really satisfying right here. Then that should swing around and pop it in. So there's still timing to work out here. I'm just going to put this guy in where it's supposed to be, just to show you guys what's going to go on. So our arm can pick it back up and take it back around. And when the sequence is done, that's going to work. I need to work on the timings a little bit. So you can kind of see what's meant to happen. There is some refinements I need to make right now. That, first of all, is the timing to how quickly this should stop. That's the first thing I need to do. Second is I need to configure this so it waits for this to come back in. Right now it's not doing so. It might be something very obvious in the code. That's what debugging is for. That's where that comes in.
I kept trying.
Now this should...
Trying.
No!
And trying.
That's pretty much perfect. That's pretty much perfect.
Each time altering the value of the time delay between when the sensor sees the block
Does it work on the,
and when it stops the conveyor motor. However, Whilst I thought I was making progress,
Oh my god, that's it. Oh my god, that's it. Oh my god, that's it.
I was in fact going insane.
Progress.
The issue with this system was that there was way too much variability in the block position, which meant that the pin was being dropped or misplaced more often than not. So we end up getting rid of this system later on and replacing it for a better one. But my struggle was not in vain. On the other hand, the end arm works fine with a delay sensor. This is because there's a bit more tolerance in that end arm for the block to be picked up. So that stays with delay till the end of the project.
Baby.
There's a lot of stuff gone into this rig. What resources did you have to start off with?
Well, I think that's a great question, You know, we didn't really have much. We didn't have any CNCs, no manufacturing, none of that. We just had mainly Fusion and a 3D printer.
What's going on with the cap? What's going on with that? The hats. What's going on with the hats?
What do you mean?
I can't see eyes. Like you're not in the shot, Kieran.
Are you being fucking serious?
Kieran,
Are you being fucking serious?
I can't see you, Kieran.
Is this a joke?
Kieran, I can't.
Is this a joke? Is this a joke? Like, I may as well get off it.
We're carrying on the interview, Kieran. Kieran, are we carrying on the interview? Can you please just sit down and chill? There you go. I can see you now.
You can't ask questions like that,
What did I say that upset you?
Don't talk about the hat. That's all I'm asking. Look, the hairline is not looking good. It's looking chopped.
Bro, the mic is in your face. The mic is in your face.
What do you mean?
What do you think It's what I'm saying. The mic is in your face. And the cap, it's not even on right. It's off to an angle. What?
Right.
You're not part of the NWA.
All right, I'm fucking done with this shit. I just don't know. It's just look at it. I mean, this shit's incredible. I mean, I've never seen nothing like this before.
Move very, very slow. Otherwise, it'll move. I may have fried it at some point before, but that's fine. We're just going to use timers for this thing. Cushions, so that the alignment won't be right.
I mean, I would never do it like that. I'm just saying. Kamala Harris, she might do it like that. I fucking wouldn't do that.
I mean, I'd fucking do it like this.
Since the last update, we've added this arm right here. It wasn't easy to assemble. There is some quirks to this, okay? It does look a bit funny right now, but it does complete a full sequence, all right? Well, we're gonna press stop. Now this bit's always worked fine. This piston feels so smooth. Brilliant. This is where it sometimes messes up. I'll explain in a second. We'll just see if this gets it right. We'll just give it the benefit of the doubt, right? Okay. You can see where I was struggling, all right? Yesterday was completing sequences willy-nilly, okay? It puts it back fine, all right? This is where this arm comes in. It's a bit hocus pocus. Boom. We'd love to see that, right? Okay, sensor's not making. And then when we get to this stage right here, this is really cool. This will come up and out and put this block over in this basket here. That's perfect. There is some little nicks in the whole system to work out. We want to do it perfect every time. The problem is right now, this sensor right here, okay? That's the problem because, so when this motor stops, this block will carry on going for a little amount of time because it slides on this surface right here. And that's actually the reason why that sometimes is knocked out and doesn't place it in right. What's the solution, okay? And you might have thought this already. We're gonna have a piston come out and be the end stop. We guarantee the position of the block every time. The whole thing is looking very messy, but we are so close to finishing. We need to do PLC refinements, we need to do tidying up, and we need to implement this, and most of all, importantly, assure reliability.
So Kieran, we are living in the world right now. The year is 2025. What's your opinion on the current political state of affairs?
It's crazy you asked that because I really hate.
I really hate him.
Right, so now we get onto the rig. So the main way that we control this rig is with this control panel, well, not panel, control board right here. We have two buttons here. One's our reset button, one is our emergency stop button. Goes to our safety relay over here. This is just a 24 volt safety relay. 2 channels, standard. We added the 3 seconds just to show that if anyone brushes by and they accidentally press the reset button, they won't accidentally hurt someone or do anything like that. So you have to hold this button now 3 seconds. It initiates that timer. There we are. So we've got a little on and off button here. So our on and off button disables 24 volts going to all of these buttons here. So none of anything will work unless that is set to 1. I don't know why I added that, it was just there. So the manual button's really just there. Once you press that start button, it will only do 1 cycle, and then that will be it. It will stop. This end stop was added mainly as a reliability thing more than anything, because we were struggling to predict the movement or the position of this block. So we added this end stop mainly just there for, to keep it in one spot, so we knew every time. This light, which I've said before, is just to indicate that we have 2 sensors here that are scanning for this thing right there. So if it does see it, the robot arm will come over, it'll pick it up, and it'll send it over there. Sorry, should I say pneumatic arm, not robot arm. This cushion end stop should go back in. There we are. This is really acting as another end stop, just to keep that in the right position. Because we've had problems where it just sends it, which that we don't want. So we're going to simulate a reject right now. So I'll just remove that. So the arm itself actually has no idea if it's picking it up or not. It doesn't have a sensor to realise that. So we've had to add this little fail-safe in, really, or this little scanning process to detect if we have gone wrong here. So as you can see, it detected it as a reject. So the first thing that it'll do is remove this little piece here, and then it should go down that reject chute, which you'll see. It should not get picked up by this arm, it should go right down there, which it does. That is the reject chute. It is either the reject chute or the overflow chute, if you want to call it that. Now if we do auto, that start button, it'll do its cycle, then it'll keep continuing as long as it detects a block there. We have a little sensor, you can see that. So that's just to detect a block there. So now, since we're still in auto mode, it should not repeat as there is no blocks in there. So you can see the arm comes and picks that up. There we are. So now we can see that the circuit has completely stopped. If we press start, it won't do anything because it doesn't detect a block in there. But as soon as you press this, there you go. It repeats because it's still in auto mode. So we have some inbuilt logic for this little arm here. We've got a sensor back here. So if the sensor detects a block here, this arm will not initiate and it'll just send it down the overflow or reject chute. So this is just to show the timeout. So we put some inbuilt timer logic. So if it doesn't detect it within a certain amount of time, just send it down the reject pile. There you are. That is the system.
Running away is easy. It's the leaving that's hard. Running away is easy.
So So how much help did you get with this project? 'Cause you were on about getting little to no help, so...
I like to be grateful, right? Let's be honest, the stuff we already did, we were good at. So that was easy, right? But the control panel, designing an entire conveyor belt system, that's not easy. You need those people along the way, don't you? Props going out to everyone on our journey. Shooters, companies, people we know. They all helped us, they all supported us, from giving us ideas to the design, to just critiquing, saying, don't do this. To everyone that helped us along the way, just a massive thank you, yeah?
It's the living that's hard, and loving you was easy. It was you leaving its scar.
Where it will go in the future, we'll just have to find out.